How important is airflow to an HVAC system? Well, it's very, very important. And if it's not right, it's not going to run right. It's funny when I see all these technicians running straight to the outdoor unit and gauging up right away without checking some stuff with airflow first, static pressure and all that kind of thing. So we have Adam Mufich from NCI, National Comfort Institute. We're going to talk to him about airflow, and we're going to talk to him about the TrueFlow Grid and how it incorporates with MeasureQuick and all that kind of stuff, and how airflow is super important. It's a very important dynamic to the running operation of an HVAC system. So let's get to this, guys. This is the HVAC Know-It-All podcast. I'm your host, Gary McCreadie.
This podcast is sponsored by Cool Air Products, Master, Cintas, and SupplyHouse.com. Go to the show notes and click on the links to check these guys out.
All right, Adam. So airflow is it's a very important aspect of a system, an HVAC system, because if it's not right, we have all kinds of problems. I mean, you know that, right? So give me on a scale of 1 to 10, how important is airflow to an HVAC system?
I mean, I think it's a 10.
Absolutely.
I agree. Yep.
Yeah, I do agree with you. So you're with NCI, National Comfort Institute. Can you let the audience know what that is and what its purpose is in the world of HVAC?
So National Comfort Institute is a training organization. We kind of go around the country training residential and commercial technicians. We offer certifications.
Okay.
We have, we write procedures. We were involved in ASHRAE 221, and just kind of trying to, the whole goal, and I guess the mission statement of National Comfort Institute is to try to elevate technicians, across the country, make them a little bit better than where they're at right now.
I like it because that's something that, I mean, this is for another conversation, but we have people running around training how to do sales and doing it a little bit in an offside way. And then we have people like yourself with NCI going around training how to do things technically correct. Because here's my philosophy on this. A sales technician that is not technically trained can, yes, go into a home and go, yes, I'll sell you that air scrubber. I'll do this. I'll do that. If I take out your burner and clean it, you need all new electrodes in there. Like, or you need a new glow coil. You need a new flame sensor, even though the ones there are fine. There's ways to make money doing it that way. But there's ways to make money actually finding problems with the system that are underlying and are causing comfort issues and are actually valid repairs. And if you know how to assess these real problems, you're going to make just as much money or more, and you're going to solve problems. And you're going to be known as a company that goes out, assesses, and when you're done, you've solved the customer a problem and you've created less headaches for them, and then you make them more comfortable. Would you agree, kind of, Adam?
Yeah, absolutely. And, by all rights, I think, if we're talking about air conditioning or heating, like I said earlier, airflow is a huge thing. And if you just start focusing on testing airflow and, measuring airflow, you're going to find so many different underlying problems, right? You have a heat exchanger that fails. You have a compressor that fails. Usually they don't just go bad. There's a reason why they go bad, right? You don't have to, to get back to the ethical part of it, as far as selling goes, I would say a good 9 out of 10 systems out there, there's something wrong with it. And if you just start measuring and testing the system, you will find it. And you can just offer a solution, right? Of something that they actually need.
Correct. I agree with you. Solution-based problem solving is how the industry should go. Not, I was watching one of Tim DeStacio's videos, and I don't know do you follow Tim on Instagram or anything like that?
Yeah, he's hilarious.
Yeah, the way he has this tendency to sort of rip apart people he doesn't agree with. I don't want to start naming names, but it was a guy trying to train how to sell, and one of the videos, the guy's like, Remy Halo and 3 UV lights on a system. He was trying to teach these techs to install 3 UV lights and a Remy Halo on the system. I was like, oh my God. I was dying laughing. Anyway, so let's talk about, this is something I've never tried. I've heard tons of great things about it. I've even talked to, I talked to Steve Rogers about it in the past in a podcast. Oh, it must have been 2 years ago now. But the TrueFlow Grid, it seems to be something that I've gotten a lot of great feedback on. Do you want to tell me what that is? Let's tell the audience what the TrueFlow Grid is.
Yeah, so the TrueFlow Grid, I initially heard about it at a conference in Florida, and I kind of saw the beta prototype, and they did a demonstration of how to measure airflow with the TrueFlow Grid, and I was blown away because, like, measuring airflow is always this like weird thing where it's kind of difficult. Am I doing it correctly? Are we going to use temperature rise? Are we using static pressure and plotting our fan airflow on a fan table? But the TrueFlow Grid is basically this plate that you slide into a filter slot,
Mm-hmm.
and then you have a micromanometer that comes with it, and you measure the supply static pressure while you slide that plate in, and you get a real-time, super accurate airflow measurement of the system. And one of the reasons why that's very important is because if you're going to plot fan airflow with static pressure, if you have a dirty system, like your blower wheel is dirty, you have a dirty evaporator coil, it's not going to be accurate. You might as well just not plot fan airflow. You're not going to get a good reading, right? So this will work in a dirty system, a clean system, anything. It's just a great tool.
Okay.
But yeah,
Okay. So my question, I mean, if you used techs out there that have measured airflow in the past may use like a hot wire anemometer type thing. And usually if it's like on because I have a lot of testo tools. I've tried a yellow jacket one as well. And they've got apps where it will give you the velocity of the air, but you have to manually enter the duct size to get your CFM. With the TrueFlow Grid, are you having to measure the duct and add that, or is it just doing it all magically for you?
It's doing it all magically. And to get back to that hot wire, that's not a bad tool. Like if you traverse a duct, it's actually like very reliable. But that being said, on a residential system, there are restrictions to get accurate measurements, right? So where you need a very straight piece of duct, and wherever you have a fitting, you should have 10 duct diameters after that fitting of straight duct with no transitions, no takeoffs. And then you need to measure 80% downstream, from that fitting.
Yeah.
So a lot of times in residential systems, you don't really have that 10 duct diameters of straight duct to make that measurement of the total system airflow. Because your goal is to try to take it before you have any takeoffs in the system, right? So ideally, that's probably at the return drop. I measured residential, airflow in residential systems with a hot wire for quite a while. And I stopped when I started to try to take and repeat my measurements over and over again. And it's very hard to get the same reading or close to the same reading. And it's really easy to make a mistake. If you're not holding that probe just right in the airstream, you can get kind of weird readings in that. So
yeah, that's why it's important to traverse and average it out, right?
yeah, exactly. But it's difficult. It's easy to make mistakes when traversing a duct. Let's just say that. But the TrueFlow, there's a correction factor based into it. You're measuring. There's different workflows you could do. You could pressure profile a system and take 4 pressure readings, and then it will give you a report on, filter pressure drop, evaporator coil pressure drop, return and supply duct pressure, as well as total external static. And then you leave the probe in the supply duct and slide the TrueFlow into the filter slot, and then you get your total system airflow. And it actually has diagnostics in it too. So it's a super accurate, and it's very repeatable. It's almost impossible to make a mistake if you follow the workflow.
Okay.
But
Before we get to anything else regarding the TrueFlow, I do want to tackle something quick because, I mean, I'm online all the time, posting, reading, replying, all this kind of stuff, and it baffles my mind. It doesn't really baffle my mind. because I should expect this in a world full of people they're online and comment. A lot of people that comment, you can tell that they're super untrained, right? You can tell, and it's not their fault, but people blurt things out all the time. They're like, "Oh, you do it like this, you do it like that," and I'm reading it. I'm like, "Where did you learn that? Like, who taught you that?" So
Yeah.
one of the things that I encounter, and you can give me your thoughts on this, Adam, is that people think that when you're checking your static pressure, like say you go and you return supply, it's a total external static pressure of the system. People believe they're checking airflow when they do that. Airflow and static pressure are two different things.
It's absolutely two different things.
Yeah.
Like, think of static pressure. Static pressure is the bursting pressure inside of a duct. So I bring her on when I do static pressure and airflow classes. I'll take a balloon with me and I'll blow up the balloon in the class. And I hold the balloon and I show a full balloon and I say, this has static pressure inside of it. There's
Yeah.
zero airflow. It's standing pressure. And we could actually measure this with a manometer. So all it is the outward force of air bursting, trying to get out of the ductwork, right?
Yeah, for
You
sure.
could use the static pressure with the performance data, the fan table, the equipment to plot fan airflow on a clean system, but it is not airflow.
Yeah. Yes. The indication I get from talking to a lot of technicians, and it seems maybe it's just like I don't know what you'd call it, but a misunderstanding or they weren't taught right in the first place, is that they think when they hook their manometer up to the system, they're actually getting airflow readings, but they're not. We got to check airflow with different tools. I mean, you're talking about TrueFlow. I said I've done it with a hot wire anemometer. There are rotating vane anemometers, but those are difficult to get inside of a duct, right? Because you
Yeah.
have to put massive holes, and how are you making sure that air's not escaping as you're putting it through this big hole? So we can talk about the TrueFlow for a minute again. Now, I know that you got to shove it in the filter rack area, but there are standard filter racks. So there's a lot of 1-inch filter racks out there that hey, listen, I got a 1-inch filter rack at home, but if I was installing a system for someone, I wouldn't recommend putting a 1-inch filter rack in. It would be something like 4 or 5-inch deep pleat, something like that. So the TrueFlow, it has to come in different sizes, obviously, to fit into the different size filter racks, right?
Yeah. So the grid itself is, I don't know, probably 12 or 14 inches by it's fairly small, right? And it has holes in the grid. And then
Yeah.
the grid will actually snap into filter plates, and they sell all different size filter plates, and you order whatever size plates that you normally run into in your market. And I mean, you don't need all the plates. There's a lot of different sizes that I would never run into in the Midwest, right? That it's probably you run into more in the South where you have big filter grills and that. But yeah, it just clips in and you take your measurement.
Okay. Now, how does this all work? Because you're with NCI, TrueFlow is made by a totally different company, right?
Yeah.
And there's MeasureQuick that's involved in this, right? So first of all, tell us who the TrueFlow Grid is manufactured by. Then we'll get into how NCI and MeasureQuick is all involved in all of this together.
Yeah. So I'll give you the TrueFlow Grid is manufactured by the Energy Conservatory in Minneapolis, right? And it's funny. I'll give you my history with the TrueFlow. I was one of the first people to buy it. I was on the waiting list when it was being manufactured. I found, I had so much success with the TrueFlow Grid that I started writing articles about it. I would just use it nonstop. And this is before I started working for National Comfort Institute, right? And when I actually took a National Comfort Institute class a couple of years back, and they were demonstrating how to traverse a duct. And they said, this is the most accurate way to measure total system airflow. And during the class, I asked the instructor, have you guys ever used the TrueFlow Grid? And he said, oh, we used it and it's not that accurate. And and he's like, there's so many hoses and everything. I'm like, are you talking about the original version of the TrueFlow from 20 years ago? Or are we talking about the new version? And he's like, I didn't even know there was a new version. So on the the lunch break for the class, I ran out to my truck and I brought the TrueFlow in and I showed him how we used it. And he compared it to his known airflow measurement on his equipment, and he was like blown away. And that was the beginning, actually, that little lunch break demonstration of the partnership between the Energy Conservatory and National Comfort Institute, which is kind of cool because that was before I even worked for the company.
Interesting. So you kind of spearheaded that whole thing.
Yeah.
Now, were the airflow readings different? Were they the same? Like
They were
what
pretty much spot on. I
Were
mean,
they?
it was yeah. So that was the beginning of it all. And then we started working on an integration, and it's actually out right now. National Comfort Institute has workflows for the TrueFlow Grid, which is really cool.
Okay, cool. Yeah, I'd like to talk about all of this, like how it integrates with MeasureQuick and all that kind of stuff, for sure.
Yeah, so we developed a partnership with MeasureQuick and the Energy Conservatory, and basically what we do is the National Comfort Institute has 3 different workflows for each one of the apps, right? We have static pressure screening, static pressure with fan table, and Air Max with TrueFlow, right? So you can actually use a different manometer. You don't necessarily need the TrueFlow Grid to use the NCI workflows, but those are just basic the 2 entry level workflows. And what that does is we give you diagnostics based on what you are reading with your own manometer, right? You don't need any additional tools, and we kind of give you guidance on what's going on with the system and the airflow.
Is this app based, the guidance, or like how is this done?
Absolutely, there's a report that generates at the end of your measurements.
And what app is that?
The TrueFlow app and
Oh, so you're
the
gonna use the TrueFlow
MeasureQuick. Yeah.
Okay.
So if you're in MeasureQuick, it's under Quick
Okay.
Tests.
Okay.
And if you go into the TrueFlow app, it's just the NCI workflows. There's
Okay. All right.
yeah.
Do you need to combine both of them together, or you can do each one separately?
You could do each one separate. And it's kind of cool too, because if you're actually using MeasureQuick for, system reporting and commissioning in that, you can use the TrueFlow to take a real life measurement, and use all your refrigerant probes and everything else to generate a report on a system. It could be in one report, or you could have 2 separate reports, whatever you'd like.
Okay, cool. All right. So what I'd like to ask you now, since we've got the information out there on how this is done, people can do some digging and some research. But some of the things you've corrected using this type of setup, what are some things that you've seen, like problems, and then how you've corrected them, and then what the results were after? Because I think that is what is going to hit home for a lot of people.
Yeah. So one of the things that, and I mean, I think a lot of people are going to have to try to do a little bit of homework on this, but if you want to look it up, I wrote an article. This really kind of sums up my process, and we'll go into it a little bit, but it's called Replacing Residential Equipment with Predictable Results for HVAC School. And what I found is when you're pressure profiling a system and measuring total system airflow, most of the time on 8 out of 10, 9 out of 10 systems, you have high static pressure and low airflow, right? And what I have found, what I like to do is I use something called Fan Law 2. Fan Law 2, if you're not familiar, it's one of the affinity laws. It's basically like if we know our static pressure and we know our airflow, we could predict our new static pressure if we have a target airflow we want to hit. Like if we started moving the new airflow, what will our new static pressure be? So I use the TrueFlow to generate a report. And then if you are replacing the equipment, you would use Fan Law 2, and you could figure out, hey, what size filter do I want to install to reduce the static pressure of the system? Or what size evaporator coil should I install to, have a lower pressure drop and reduce our total static pressure? What ends up happening if you use it correctly, you could increase your total system airflow while still decreasing your static pressure, which is huge. Because when you start measuring static pressure and airflow don't move at the same rate, right? So if you double your airflow, you're not going to double your static pressure. Static, it moves at the square of airflow. So it actually, if you change your airflow a little bit, your static pressure is going to move more. It swings farther in the same direction, right?
Yeah, this is deep nerding out stuff right here.
Yeah. Sorry about
So
that.
no, that's totally fine, man. I invite all kinds of conversations like this, and deep nerding out is sometimes needed to understand what the heck is going on. Okay. So here's what I wanted to throw at you here. And you can tell me if your experiences are the same or different. I started to dig deep on like I don't really do much residential work anymore. When I left the contractor that I was with for 22 years, I started doing some resi work, and I started to dig a little bit deeper on how to do things right from the install level up, right, to service, because
Yep.
I wasn't a residential guy. So, and residential and commercial, they're two different things. And I've never liked when a commercial guy goes, "Oh, you just do resi. You just do resi." But a commercial guy can walk up to a residential piece of equipment he's never seen before, and he's caught up, right? He doesn't know how it's supposed to function and how it works and what that thing does. So they're two different animals as far as I'm concerned. But what I'd noticed, right? And I started to do this with these heat pumps that I was putting in. There's people that, yeah, I want to put a heat pump in. I had to do one for basically they were a supplier of heat pumps, so they wanted me to put one in their house, and they didn't care how much it cost. They just wanted to do it right. So we went out, we did load calcs, all this kind of stuff, and I started to repeat the process. And what I was finding when it comes to the air side of things, right? And everybody says ductwork is undersized all over North America, and I'll agree that it probably is in a lot of cases. But what I was finding in this area is ductwork didn't seem to be undersized once the equipment was correctly sized. It seemed like the equipment was too big and it was moving too much CFM through the duct, so the airflow was reduced, the static pressure was high. But as soon as you do a load calc and you throw in the right size of air handler, your airflow and your static pressure are just fine. Have you noticed anything like this?
That's exactly right.
Yeah.
I love that you said that, because that's like one of the biggest points that I try to hit home with people, in these classes, is they're like, what is the number one thing you could do to fix airflow in a system? And I always say, size it right.
Yeah.
Install the correct size equipment, which usually means reducing the size of the equipment. Because remember what I just said, static pressure moves at the square of airflow. So if you reduce your airflow a little bit, or you reduce your airflow requirement a little bit, your static pressure drops even further.
Mm-hmm.
So it's like an easy win without doing any metal work, right?
Yeah. Like I remember putting in this one. It was one of the first heat pumps I did when I was on my own. And I remember putting it in and measuring the static pressure. And I was looking at the ductwork, and I was very concerned because the house was all finished, drywall ceilings. There's no way you're getting into rip the ductwork out. There's no way you're doing it unless the homeowner was paying a lot of money to do it, but they were actually planning on moving. So it wasn't going to happen. So we did our best to size the unit as aggressively as we could. And when I put my manometer across it, the static pressure was like 0.3 or something like that. It was, or 0.2. It might even been lower. And previous to that, it was higher. And I'm like, interesting. And that's when I'm like, and I started to think, and then I started to look deeper into this. And it was just, I just found it very interesting that everybody's always telling me ductwork is oversized, but I'm starting to think the ductwork in a lot of cases is fine. It's just the equipment's too big, just moving too much air.
I think you're 100% right on that. You nailed it on the head. One thing I would say is probably the case with systems that have 1-inch filters installed. The filters are 100% usually undersized in most cases, in my experience. So if you are replacing the system, even if you are reducing the size, explore the options of 4-inch and 5-inch, like you were mentioning earlier, right? And go as big as you possibly can. There's really no reason, unless you're really restricted on space. But the smaller size media filters, like the 16 by 20s and that, if you could do a 20 by 25, if you could do a 25 by 25, or even multiple media air cleaners, all that does is reduce the pressure drop across the filter, which ultimately lowers or reduces the total external static pressure of the entire system.
Of course it does. So maybe you can, I've talked about this till I've been blue in the face, but let's get your perspective from, so the audience can get this from someone else. And people don't understand this. They think, if I put in a 5-inch filter, it's so thick. How's the air even going to get through that thing? Explain to the audience why going with a deeper pleat is much better than going with the 1-inch pleat.
So it's all about surface area. It's about square foot, how many square foot of filter media do you have? So if you have a 16 by 25 by 1-inch pleat, if you were to cut that filter apart and straighten it out, so it was like one piece of flat media, and then you took a 16 by 25 by 4 or 5-inch filter and cut it apart and stretched it, right? You would have it would be so much more, it was so much longer, and you'd have more square footage of filter. So what you're doing is you have more surface area for more airflow to move through. You're not trying to force it all through a smaller space, right?
Yeah. Yeah. So I remember being on a podcast with, I believe it was, because I've done a few podcasts with April Air, and I believe it was the first one I did with a gentleman by the name of Brandon Glancy. I don't know if you know who he is, but he works for April Air. And I was talking about the same thing with him about the 1-inch versus, and I used the word that it didn't set him off. He's like, I'm glad you said it like that, because this is why people have this sort of idea in their head. I use the word thicker. It's a 5-inch thick filter, and that's not really the word that we should be using. It's 5-inch deep filter, because it's not like the filter is 5 inches of media that you have to pass through. It's just the pleat is 5 inches deep, right? It's the same. Like if you take a MERV 8 1-inch, MERV 8 5-inch, the amount of the material that it's going through is the same, for a lack of a better term, thickness for what you know what I mean? It's just the pleat is deeper. So as you said, more surface area. If you took it out, you took a 1-inch out and you took a 5-inch out and you cut the frame around it and you open that material up, well, you got tons more material in that 5-inch.
Yeah.
So there's more airflow going to go through it. We're going to catch more particulate. So it's just a better filter all around to go that route, right?
Yeah, and another thing too to think about is the speed at which the air passes through the filter. So the lower the velocity that the air flows through the filter, the better job it's going to do at catching particulate. So if you have like an undersized 1-inch filter and it's not the greatest filter rack or frame or whatever, you'll not only have dirt and air passing around the filter, you'll have dirt passing directly through the filter. It would just, it's filter bypass. It's traveling so fast, it's going to make its way right through the filter. If we could slow that dirt and air down, the filter does a much better job at collecting the dust. And
I 100% agree with you. And that's something that a lot of people don't think about, is the bypass around the filter. And I mean, I've had this debate with a lot of people. I don't know. You might be able to tell me this. Maybe you know. So white slime in Florida, right? High humidity scenarios. Can we get rid of, or do you know a case study or someone that's tried this? If we design a system properly to have the right filter, no bypass, can we reduce white slime? Because there's filter companies out there, and April Air is one of them, that will guarantee that your evaporator will not get dirty if the filter rack and filter is installed properly. So if we're not getting any of that particulate by, how are we creating white slime if there's nothing on there to cause that? Like, have you seen any studies like this or been involved in anything like that?
There's High Side Chemical. They did a study on trying to figure out what that was. They actually sent the microbes or whatever it is out to, I think it's called biofilm, right?
Okay.
They sent it out to a lab to figure out what it is, like what's in it. And what they found was it actually comes from, most commonly it comes from like outside in the grass. It gets picked up in your shoes and you bring it in. And it's just like little organisms or whatever that will grow on an evaporator coil. Will a good filtration system stop it? I mean, maybe. I don't know. Like, I don't have any experience. I'm in the Midwest. We don't really run into that. But I will tell you this, just following, I'm sure a lot of your listeners and you as well kind of follow Jim Bergman from MeasureQuick, right? He puts out great content all the time. But one of the things that he says is if you have a trap or a drain in, on your evaporator coil, if you're filtering your air properly, you should never have to clean that. You'll never have dirt in your trap or drain, right? You just don't have, there's no place for it to come from. So
Yeah.
I would just kind of to talk on that a minute, like I would think that if you have an awesome filtration system that's really doing a really high, great job of filtering the
Mhm.
air,
Yeah.
I think it's going to at least slow down that biofilm or that white slime. You know what I
Yeah.
mean?
And I will be honest with you. There's a lot of people that may disagree. I've even read articles that say they're complete scams, but a properly installed UV light that fits the application to shine down on the coil and the pan. I mean, there's been published results saying this also helps as well. Do you have any thoughts on that?
I think a UV light's going to help anything, but I'm not sure about that white slime because I think a lot of it actually grows inside the drain itself. I know that high side chemical makes some type of solution that you would kind of dump down the drain,
Hmm.
and then it's supposed to last for up to 6 months or something like that, and then you have to kind of redo it over again. But the UV light, I'm not 100% sure if that would cure it or not. I've known people to actually stick pieces of copper in the
I've heard
drain,
that. I've heard
or
that.
copper in the drain pan, right, to try to prevent it.
I've heard they've had to do that with aluminum coils
Yeah.
because there's some sort of reaction that does something to the white slime. There's a unique product that I actually just made a post about this the other day, and I was looking for feedback because I've never personally tried it. And I know we're getting away from airflow, but it kind of ties together because it's coming out of the drain pan that the air is moving by. But there's a product called Clear Drain from RectorSeal. It's a green PVC. Actually, it's right in front of me. So apparently it's somehow constructed with zinc or something like that. And people have told me that this is actually getting rid of white slime because it's reacting with whatever's in the water, and it's basically eliminating it. So it's actually kind of cool to see products like that as well.
Yeah, I'm curious to see. I have a couple friends in Florida, see if they've tried it, you know what I mean? Because I know that's a
Okay.
huge issue down in Florida.
Okay. So back to the topic at hand. Is there anything else you want to throw out as far as the whole airflow thing, TrueFlow Grid, NCI, MeasureQuick?
Yeah,
Is there anything
I
else you
think
want to throw at us?
I would recommend anyone and everyone listening to this that does residential, download the MeasureQuick app, download the TrueFlow Grid app, and start playing with the NCI workflows, right? You don't necessarily need the TrueFlow Grid, and you could start actually using the diagnostics. It will
Hmm.
help you level up your game. And then eventually, if you want to save up and pick up the TrueFlow Grid, that's just the next level, right? Um,
Why? How
it's
much is it? Do you know how much it costs roughly?
I want to say it's around 1,500 with a handful of the filter plates.
Hmm.
So what that is you get the TrueFlow Grid, and then you have another micromanometer, which the micromanometer is pretty cool in itself because it's super accurate and it has such a small, it measures not only in inches of water, but also pascals. So you could do house pressures with that. You could measure room pressures. It's a pretty useful tool.
Cool. Awesome, man. Well, this was a good conversation. I appreciate it. I've yet to try the TrueFlow Grid. I want to. This might actually spark an email after the show's done to
Go
get my
for it.
hands on one to maybe even do like an educational series or something. I don't know. But anyway, Adam, thank you very much for this. I appreciate it.
Oh, no problem. Thanks for having me.
No problem, man.